Good morning. It's June 4th, and this is your daily brief in science. Here's everything you need to know. NASA has ended the MAVEN mission after losing contact with the Mars orbiter, ending more than a decade of atmospheric study. MAVEN helped illuminate Martian weather, relayed data from surface rovers, and even captured a stray interstellar comet in recent years. Launched in November 2013 from Cape Canaveral on an Atlas V, MAVEN reached Mars after a 10-month journey and exceeded its one-year goal by operating far longer. The mission supported Mars relay networks, serving as one of 5 spacecraft providing communications between orbiters and rovers. NASA notes the relay network still has 4 other operating spacecraft and has adjusted operations to stay resilient, with Mars Odyssey, Mars Reconnaissance Orbiters, Europe's Mars Express, and the Trace Gas Orbiter continuing to function as relays. MAVEN's data assisted Perseverance and other rovers, and its results influence current and future Mars exploration concepts, including a 2030s Mars Telecommunications Network initiative with international and commercial partners. Beyond science, MAVEN handled about 8% of relay sessions and delivered roughly 18% of total data thanks to a new coding scheme, reflecting a notable contribution to Mars communications. NASA says the spacecraft relayed data from active rovers Curiosity and Perseverance through the relay network and will investigate the failure to learn lessons for future missions. Officials emphasized MAVEN's data will continue to provide insights for decades, with a planned briefing to discuss its legacy and what comes next for Mars science and relay networks. 2 leading research centers have tested a dual CAR T-cell therapy to desensitize highly sensitized kidney patients, enabling donor kidney transplants that were previously unlikely. The Phase 1 trial from Penn, NYU Langone, and Mass General shows near 100% CPRA reductions in 2 patients, allowing compatible donor kidneys and no donor-specific antibody rebound or organ rejection so far. The study, published in the New England Journal of Medicine on June 4, describes 2 initial patients and a third later, all receiving kidney transplants after CAR T-cell-based desensitization that lowered anti-donor antibodies and CPRA scores. The trial design aims to minimize severe adverse events, with B-cell populations gradually recovering after treatment. Higher dose cohorts and more patients will be studied in future phases. The collaboration is funded by NIH and institutional sources, with future phases planned to test higher CAR-T doses and more participants to assess safety, durability, and effectiveness. The study is supported by Penn's Center for Cellular Immunotherapies, Gift of Life Donor Program, NIAID funding, and additional support from Blood Cancer United and the Burroughs Wellcome Fund. Led by Ali Naji, MD, PhD, the Penn-NYU Mass General effort is part of the Clinical Trials in Organ Transplantation Consortium and highlights translational work from CAR T-cell technology in oncology to transplant immunology. First authors and leaders say the work demonstrates that CAR T-cells can help patients gain transplant access, potentially changing outcomes for thousands on waiting lists. This work reflects Penn Medicine's leadership in cellular therapies and broad collaboration across institutions. Safety and tolerability were generally favorable, with transient B-cell and plasma cell depletion and manageable safety profiles, differing from some cancer CAR T-cell therapies in adverse events. The findings appear in NEJM, with the clinical trial registered as NCT060560012, and accompanying institutional press materials provide further context on the study design and progress. A new interdisciplinary modeling framework from Florida State University aims to clean internal tide interference from SWOT satellite readings, boosting observation accuracy of ocean circulation by about 60%. The approach uses HICOM, a physics-based ocean model, to remove internal tide signals and improve high-resolution surface measurements from space. Researchers from FSU and collaborators wove ocean physics, data assimilation, and remote sensing to capture nonlinear interactions among internal tides, currents, and bathymetry. The study is published in Science Advances and reflects collaboration across multiple institutions, including the University of Michigan, Oregon State University, the Naval Research Laboratory, the University of Southern Mississippi, and CLS Group, with funding from the Office of Naval Research, NASA, and CNES. Lead author emphasizes cross-domain cooperation to leverage satellite observations and ocean modeling expertise for coastal and open ocean processes. The framework integrates physics-based modeling with satellite data to address internal tide effects on SWOT's readings. This work moves toward real-time ocean modeling tied to continuous satellite monitoring, enabling finer-scale dynamics to be observed from space. The method could refine processing of orbital sensor data and increase the precision of global ocean observations, including heat and carbon exchange. Improved accuracy supports better climate model verification and may yield benefits for navigation, infrastructure planning, and fisheries management. By correcting internal tide interference, SWOT can better observe eddies and currents, enhancing insight into ocean atmosphere heat and carbon uptake, and enabling broader applications. A new milestone in quantum error correction is unfolding as atom computing reports sustained quantum error correction on a neutral atom platform, marking a meaningful step toward fault-tolerant quantum computing. The company says it achieved repeated, extended error-correcting cycles, advancing the pursuit of practical, error-resilient quantum systems. CEO Ben Bloom calls the result historic for fault tolerance and notes competitive performance of neutral atoms compared with superconducting qubits. This places atom computing among a small group showing many rounds of sustained error correction, reportedly the first such demonstration with a neutral atom architecture. Observers caution that errors still accumulate over long sequences, signaling that optimization remains ongoing. The achievement sits within a broader landscape of quantum architectures, including superconducting qubits, with experts like Scott Aronson and Matthias Treuer endorsing the work and highlighting improved fidelities through error correction. The technical setup features dynamic qubit rearrangement for all-to-all connectivity, a zoned architecture for parallel operations, and record-long coherence times of nuclear spin qubits to support faster, flexible computation. Atom computing's approach enables moving qubits to enable connectivity and parallelism while preserving coherence, a combination seen as a strength for scaling. Analysts see this as a major step toward a neutral atom platform capable of continuous operation and industrially relevant tasks, though there is acknowledgement that further reductions in error rates and increases in speed are still possible. In the experiment, the group increased error-correcting qubit counts from 16 to 32 without introducing new errors, with some signals pointing to lower error rates at larger group sizes. The company's commercial footprint is expanding, including the world's first commercial quantum computer with logical qubits sold to QNorth, collaborations like Magne with Microsoft, involvement in DARPA benchmarking, and pursuit of a substantial funding agreement with the U.S. Department of Commerce. A new map of the universe's magnetic fields is being released, based on data from the ASKAP radio telescope in Western Australia, offering the most detailed view of cosmic magnetism to date. Scientists combine the rapid ASKAP continuum surveys with a SPICE-RACS component to chart magnetic fields across the Milky Way, the Magellanic Clouds, and beyond, using light twisted by magnetic fields to infer strength and orientation and render color-coded maps. The release covers light from nearly 4 million galaxies, making SPICE_RACS the largest and most detailed magnetism map yet. The project shows magnetic fields influencing star formation, slowing it by about a factor of 3, and guiding interstellar wind propagation, thus impacting galaxy life cycles and gas and dust distribution. Researchers describe the SPICE_RACS map as a foundational resource that will drive future studies of regions, star-forming zones, and individual galaxies. The data is openly released for global use, inviting analyses from scientists worldwide through CS1RO repositories and the Astronomical Society of Australia. Lead author Dr. Alec Thompson and co-author Prof. Naomi McClure-Griffiths say magnetic fields permeate Earth, stars, galaxies, and intergalactic space, with origins and evolution remaining major cosmology questions. The maps position magnetic fields as a key driver of cosmic structure, potentially rivaling gravity in shaping the universe by influencing material flows and galaxy interactions. The project supports fundamental physics by enabling detailed studies of magnetic structures to address how cosmic magnetism began and evolved since the Big Bang. A large collaborative effort produced the SPICE_RACS map, and experts anticipate major breakthroughs in coming years as researchers study specific regions and galaxies using the dataset. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.